Welcome back to my channel. This is Mr. Ibarra, and today I'm gonna show you how to solve and understand permutations and combinations. Okay, so let's understand first the difference between permutations and combinations. So for permutations, this is just arranging things in a definite order. Again, arranging things in a definite order. And combinations, it's just combining things, selecting things from a group. Okay? But what is the distinct difference of permutations and combinations? Okay. So for permutations, the order matters. Again, the order matters or the arrangement matters. But in combinations, the order does not matter or the arrangement of things does not matter. I know you can understand it with an example. Let's have these three letters first. Okay? And we are asked to arrange it in a different order. Okay? So under permutation, okay? So how many ways can we arrange this? So under permutation, there are two. Okay? So since the order matters, it's 2. So GOD, GDO. Okay? But in combinations, it's just 1. Why? Because whether it's GOD, whether it's GDO, or another way around, it's just the same. It's just the same thing. Okay? So we're just going to count it 1 in based on combination. Let's say we have these 4 letters, okay? And we are asked to arrange these 4 letters or in how many ways? So we are going to take 2 out of 4, okay? So the first arrangement will be L, O. Next one, L, V. Next one, L, E. O, L, O, V. OE, VL, VO, VE, EL, EO, and EV. Okay? So, how many arrangements that we made? Okay? So, under permutations, since the order does not matter, so we are just going to count everything here. In permutation, the order matters, okay? So we are going to count everything in here. So LO, OL, BL, all of these are counted. So there are 12, okay? So there are 12 ways. Next, under combination, okay? So under combination, since the order does not matter, look at this, okay? So LO and OL, okay? So under permutations, this 2 is counted as 2, okay? But under combination, since the order does not matter, okay, the arrangement of these 2 letters is not important, we're just going to count them as 1, okay? So OL, how about OV? So OV, so BO is not counted. OE, EO is not counted. LV, VL is not counted. LE, EL is not counted. VE, EV is not counted. Okay? So under combinations, so how many ways can we form 2 out of 4? So there are 1, 2, 3, 4, 5, 6. So there are 6 ways. Is there any other way to solve this problem easier? So the other way to solve for this permutation is by using this formula. Okay, so NPR is equal to n factorial over n minus are factorial. Okay? So where n is the total number of objects and total number of objects, and r is the number of objects to be taken at a time. Okay, so let's use this at this problem. Okay, so what is the total number of the objects? Though there are 4, so 4p. So we are going to take 2 objects or 2 letters at a time. So 2. So 2 permutation 4. Okay, so 4 factorial, let's substitute, n factorial minus 2 factorial. Okay, so 4 minus 2 is 2, so we have 4 factorial over 2 factorial. Okay, so what exactly is 4 factorial? So it's just multiplying the numbers. Okay, so 4 times 3 times 2 times 1. Okay, multiplying numbers up to 1. Okay, next, so 2 factorial, so of course 2 factorial is 2 times 1. Okay, so looking at this equation, 2 times 1 and 2 times 1. Okay, so they will be equal to 1, so we can cancel it. So 2 times 1 times 1 is cancelled. So we have left with 4 times 3. So 4 times 3 is 12. So as you can see, it's just equal. Okay? Next, how can we compute for the combination? Okay? So for combination, we have this formula. N CR is equal to n factorial over n minus r factorial times r factorial. Okay, so again, so where n is the total number of the objects and r is the number of objects to be taken at a time. Okay, so we have total number of objects or letters here, so 4. So 4 combination, so our r is 2, since we are going to take 2 letters at a time. Okay, so let's just substitute. So 4 factorial over 4 minus 2 factorial. 2 factorial, so this is equal to 4 factorial over 2 factorial times 2 factorial, since 4 minus 2 is 2. Okay, so let's substitute. Let's do the factorial. So again, multiply all the integers all the way to 1. So let's just type 2 times 1 times 2 times 1. Okay, so since again 2 times 1 is and divided by 2 times 1 will be equal to 1, so we can cancel this. So we have left with 4 times 3 over 2 times 1. So let's observe, 4 divided by 2 is just 2. Okay, so we are left with 2 times 3. So 2 times 3 is equal to 6. So there are 6 combinations when you are going to take 2 objects at the same time. Okay, so now you already understand how to solve permutations and combinations using the listing method and using the formula. And now let's work on some problems here. Okay, so the first problem is, in how many different ways can you arrange 3 books on a shelf from a group of 7? Why is it in a shelf? So the first thing that you have to answer is this a permutation or a combination? Okay, since as you can observe, the arrangement of books matters. Okay, so we are going to arrange books. So usually when you encounter the word arrange in a word problem, typically it's permutation. Okay, so we are going to use the formula for permutation, which is n factorial. So n factorial over n minus r factorial. Okay, next. So since we already have this formula, we can substitute the given. So so what's the total? So there are 7 books, then you're going to arrange it. Okay, so you're going to take 3 books at a time from 7. Okay, so let's substitute. So 7 factorial over 7 minus r, 3 factorial, sorry, 3 factorial. So 7 factorial is just 7 times 6 times 4, sorry, times 4 times 5 times 4 times 3 times 2 times 1, again all the way to 1. And 7 minus 3 is 4 factorial, so 4 times 3 times 2 times 1. And as you can observe, ito 4 times 3 times 2 times 1, when you divide it by 4 times 3 times 2 times 1, it's just 1. Okay, so we can cancel it. So 7 times 6 times 5. So 7 times 6 times 5 times 6 times 5. So let's use a calculator for this. So that's 210. Next question. So in how many different ways can we arrange 5 books on a shelf? Okay, kalimutan ko na naman yan. Anyway, so analyze again if this is permutation or a combination. So again, we are going to arrange, okay? So we are going to arrange. So again, the order matters, okay? But we can actually solve this problem using counting techniques, okay? Or the multiplication rule. So let's say we have 5 positions, okay? 5 positions for the 5 books, okay? So since you put already the first book here, okay? So you're just left with 4 books, okay? So since you already positions 2 books here, you are just left with 3. You put already the 3 books here. You are just left with 2 and 1. Okay? So using multiplication rule, we can get the number of arrangements of 5 times 4 times 3 times 2 times 1. So 5 times 4 is 20 times 6, 60 times 2. So there are 120 ways we can arrange this. Okay? But using the formula for permutations, let's see if this is equal. So n PR is equal to n factorial over n minus r factorial. So the total of books is 5, and we are going to arrange the 5 books, again the 5 books out of the 5 books given. So there are our R here is 5. So 5 permutation 5. Let's substitute. So 5 factorial over 5 minus 5 factorial. So just 5 factorial. 5 minus 5 is 0 factorial. And there is something that I need you to know. Okay? So 0 factorial is always equal to 1. And it is just the way it is. Okay? And we are going to solve this, or the reason why 0 factorial is equal to 1 in the next video. Okay? So please stay tuned. So 5 factorial, so this is just this. So 5 times 4 times 3 times 2 times 1 is equal to 120. So 0 factorial is just 1, so 120 over 1 is just 120. Okay, next problem. So how many teams of 4 can be produced from a pool of 12 engineers? Okay, so I forgot question mark. So let's analyze this problem. How many teams of 4 can be produced from a pool of 12 engineers? So is this permutation or a combination? Okay, so notice that in this problem, if you list 12 engineers, let's say we have Santos, we have Velasco, Reyes, or Vertusio. Okay, so the order of them does not matter as long you form 4 teams. Okay? Again, the order does not matter here. Okay? So we are going to use the formula for combination. So NCR is equal to n factorial over n minus r factorial times r factorial. Okay? So our total number, so 12. So 12 combination. So we are going to take 4 teams from the pool of 12 engineers. So that's 4. Let's substitute. So 12 factorial over 12 minus 4 factorial times 4 factorial. Okay? So this is equal to 12. Again, multiply it all the numbers until 1. 12 times 10, 11 times 10, times 9, times 8. Okay? And I want you to stop at this. Okay? I'll explain later. Okay? So 12 minus 4 factorial is 4 factorial. Okay? I mean 8 factorial, sorry. Next, 8 factorial, then times 4 factorial. Okay? So notice that when we are going to form this, okay, multiply this all the way to 1, 8 times 7 times 6 all the way to 1, it's just the same with 8 factorial in the denominator. So we can cancel this. Okay? And we can continue 4 factorial. So 12 times 11 times 10 times 9. Okay, so 8 factorial is already cancelled. So 4 factorial. So 4 times 3 times 2 times 1. Okay? So 12. Okay? So I think we can still cancel this. So 4, notice that 4 times 3 is equal to 12. So there is 12 here. So 12 divided by 12 is just 1. So definitely we can cancel this one. Okay? Next, we all know that 10 divided by 2 is just 5. Okay? So we can simplify this as 5. So we are left with 11 times 5 times 9. Okay? So I know that 11 times 9 is 99 times 5. Okay? So if you don't have calculator, let's see. So remember, 99 is equal to 100 minus 1 times 5. Okay? So we can distribute 5 to this equation. So 500 minus 5 is equal to 495. So that's the answer for this problem. Okay, one last problem that I want to show you is this type of problem. Okay, so how many permutations can be made from the letters of the word Pacifico? Okay, or how many ways can we arrange these letters? Okay, so in order to solve for this, so again we are talking about arrangement, so we are going to use the formula for permutation. Okay, but under permutation, there's another one type of formula that we can use to solve this type of problem. So n, take note of this, n PR is equal to n factorial over n sub 1 factorial times n sub 2 factorial, n sub 3 factorial, and n sub k factorial. Okay, so what are these n's? Okay, so these n's are cells or just representation of objects that are on the same kind. Okay, but let's understand this problem formula using this type of example. Okay, so n factorial again, so this is the total number of objects. So here in this problem is the total number of letters. So how many letters do we have? 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 letters. So 8 factorial over or divide to the letters that repeats. Again, letters that repeats. So how many letters that repeats here? So we have C. So there are C is equal to 2. So there are 2 C. So 2 factorial times again the letter that repeats. So 1. So there is I. Okay? There are I. 2 I's. Okay? So I is equal to 2. So that's it. 2 factorials. Okay, so as you can see, well, there are no letters. There are no other letters that repeats. So 8 factorial, 8 times 4 times. Sorry. It's too late. So 8 times 7 times 6 times 5 times 4 times 3 times 2 factorial, since we can cancel 2 factorial down here. Okay, so 2 times 1, so we can cancel this. Okay, so 2 times 1. Okay, so let's simplify the numbers here. So we all know that 4 divided by 2 is just 2. Okay, so we can simplify this. Okay, let's multiply. So we are left with 8 times 7 times 6 times 5 times 2 times 3 all over 1, but it's just a whole number. So 8 times 7 times 6 times 5 times 2 times 3. So there are 10,080 ways to arrange, okay, these letters. 10,080. Now let's proceed with a common type of problem that we can encounter in permutations. Okay, so how many ways or how many permutations can be made from the letters of the word Mississippi? Okay, so we're just going to do the same thing like we did earlier. So we're going to use the formula for permutations. Okay, so n, so how many letters do we have? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Again, let's count it. So make it sure, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 11. So 11 factorial. Okay? 11 factorial divided by the letters that repeats. Again, the letters that repeats. So what are the letters that repeats here? So we have S. So S, let's cancel S. 1, 2, 3, 4. So 4 factorial. Okay, next. I. So how many I do we have? 1, 2, 3, 4. 4 factorial again. And lastly, we have 2 p's. 1, 2. So 2 factorial. Okay. So let's solve for this now. Okay. Let's see if we don't have letters that repeats here. Okay. So 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4. Okay, I want you to stop at 4 factorial. Since we have 4 factorial here, so we can cancel it. So 4 factorial times 4 times 3 times 2 times 1 times 2 times 1. Okay, so since 4 factorial divided by 4 factorial is just 1, so we can cancel it. Okay, next. So looking at this example, so observe that 8 and 4 can be simplified. So 8 divided by 4 is just 2. So we can cancel this. So we are left with 2. So 2 divided by 2 is just 1. Okay? Or 4 times 2 is 8. 8 divided by 8 is equal to 1. Okay? Next, observe 3 times 2. So 3 times 2 here is equal to 6. So I think, okay, we can cancel 3 times 2 here and 6 here. Next, we are just left with 1 times 1. So 1 times 1 is just equal to 1. So we are left with 11 times 10 times 9 times 7 and times 5. So I believe the answer here is 34,650. Okay? And that's it for today. I hope you've learned something from this video. And please click like and subscribe for more videos. Thank you.